Hello and welcome back to Every Problem. This is Stewart Calculus, section 1.1. Oh, well, it's the 8th edition of Stewart Calculus, section 1.1, problem number 63. 63 is a word problem, as we can see, right? And it says, a box with an open top is to be constructed from a rectangular piece of cardboard with dimensions 12 by 20. By cutting out equal squares of side x at each corner and then folding the sides up as in the figure. So express volume V as a function of x. Okay, well, let's see. What we're going to do is actually something similar with all the other problems before these, if you were watching them or not. But what we'll need to do is we'll need to have two equations that we set up. And that should help us find a good way to measure the volume. So let's go ahead and start with just a standard volume function, actually. And we'll say that, volume is equal to length times width times height, okay? So we sort of have to imagine this in our mind. Unfortunately, there's not too easy a way to demonstrate it, but this x here, right, if we look at this, suppose we folded that up, right, to make one of the sides, this side right here, we fold that side up. Well, if it's length x and we fold it up, then that means our height is going to be equal to x. So the height equals x, okay? And, well, let's call this our width here, this 12. Let me erase some of this first, just so that way we do one step at a time. And actually, I think I was mistaken. I don't think we need two equations for this. I don't think we need surface area and volume. I think we just need to make sure we get all the side lengths correct. So now how do we do this, right? We have 12. We know that this is 12, but there's some spots cut out of the box. So we have to figure out this length here. Well, instead of figuring out in just a single numerical answer, we can actually get a little bit more of an implicit idea of it. So for the width, right, we have 12, but here we have these x's, and it's also x on this side too, because it said they cut out squares, so we can confidently say that all sides of the square are length x, okay? So there are two x's, 1 and 2, which means that the length is going to be 12 minus, or did I say length, the width? The width is going to be 12 minus 2x, okay? And what about the length? Well, first let's go ahead and erase some of this. That way it's a little bit easier to deal with. And we'll do exactly the same thing here, actually. Well, here, with the length, we have 20. And there's also those squares, right? And every side is going to have a length of x. So because there are two x's here, then we are going to have a length of 20 minus 2x. And that will give us the length part of our box. Now, with all of that said, that's actually everything we need. And we can just say that the volume is equal to x times 12 minus 2x times 20 minus 2x. And that's going to be the answer for our volume function. In the back of the textbook, it does say, I think it says something along the lines of That's the volume function so long as all values of x are less than, not less than, are greater than 0. So if you want to be that specific, then, by all means go for it. But in general, we're going to assume that our lengths of the box are going to be positive. So either way, this function here is the answer. So thank you.